Hi everybody, it's Miss Billingsley again. Today we are going to be taking our very last notes for this unit. I know it seems like we're cutting it short, and that is because we're going to end the unit a little bit sooner than expected. But this is something that we need in order to finish our house project. So today we are going to be learning about composite solids. Okay, so composite solids are solids that are made up of two or more solid figures. So it has, multiple solids or 3D shapes stacked onto each other or cut out of one another. So let's get started with a volume example first. If you have a printer at home, you can stop here and print these notes out. They are attached in the agenda. If not, you can draw sketches and follow along with me in your notebook. So let's dive right in. Our volume example has this house-looking shape. Okay, so this is one idea that we could use for our actual dream houses. So what we first need to determine is what figures or what solids this is made up of. So let's try to determine that. Very good. So this figure is actually made up of a square pyramid, okay, on top, and it is stacked on top of a rectangular prism, okay? Or actually it's rectangular. The base is square, but the height is not 15, so that it can't be a cube. So we have a rectangular prism and a square pyramid. So in order to find the volume of a composite shape, we need to find the individual volumes of each figure, and then we're going to add those together. So first, let's find the volume of our rectangular prism. Okay, so it's a good idea to pause right here and grab our formula sheet so that we have everything on hand. I also have my calculator ready to do some calculations. So we're finding volume of a rectangular prism, and I need to multiply the base area times the height. So my base area is going to be 15 times 15. And then we're going to multiply that by the height, which is 10 inches. Okay, let's see what that is. Very good. The total volume for our rectangular prism is 2,250 inches cubed. Okay, so that is part of our composite solid. Now we need to find the volume of our pyramid over here. It is a square pyramid, so to find the volume of a pyramid, we need to take a third times the base area and then times the vertical height. So that height there in the middle is this 8 here. And our base area is going to, again, be 15 times 15, and then multiplying that all by 8. So let's type that in our calculator and see what we get. All right, 600 inches cubed is what we get for our area of our pyramid, okay? And to find the total area of the composite shape, we need to add those two together. So the total volume is going to be 2,250 plus 600, and what does that give us? Very good. 2,850 inches cubed is our composite volume. So this is one of our tasks and our need to knows on our project. So we're going to need to find the volume of our dream house as well as the surface area of our dream house. So there is one example for us. Next, let's take a look at surface area. So the other thing that we're needing to find for our dream house is the surface area. And of course, it's going to be of a composite figure like the ones that we see here. Multiple things put together to make a house. So for our surface area example, I have this cylinder here, and what shape is cut out of the cylinder? I see that something is missing. Very good. Really what we're working with is a big cylinder with a radius of 9 meters. And then inside we have this cutout piece whose radius is 5 meters. Okay, so what we need to do for surface area, it's a little bit different and trickier than volume. We actually need to find the total surface area of each shape and then subtract the pieces that we do or don't need. So I notice here that the whole outside ring is present as well as a piece of the big top, and that middle circle is cut out on top and bottom. And then this piece right here, the inside ring, is actually this ring right here. So this one's a little bit tricky. We're gonna need to find a bunch of different pieces and then add and subtract them all together. So first, let's find the surface area of our cylinder over here. Again, looking at my formula sheet, we have P times H plus 2B. And remember, perimeter is P, H is the height of the cylinder, and then 2 times the base area. So first I need to find my perimeter, which is circumference for a circle. So I'm going to take 2 times pi times my radius, which is 9. Then I'm going to multiply that by the height, which is 3 meters. And I'm going to add on the 2 circle bases. So 2 times pi r is 9. And then squared. Okay, lots of things to type in here. Let's go ahead and type that in. Decimal is fine. You can also leave it exact by not typing in pi, but I am going to get the decimal approximation. Okay, my surface area of my large cylinder is about 678.58 meters squared. Okay, so that is my big cylinder. Notice that we subtract parts of the small cylinder, and then we're going to have to add back on the outside ring. So let's do that next. I'm going to be using the same formula since I have a cylinder again, but I'm going to be strategic so that I don't make more work for myself. I don't really need the total area of this cylinder. What I need is the bases, because that's what I want to subtract, and then I want to add on that outside ring since it's part of the surface on this composite shape up top. So we're going to actually split up the formula. First, let's find the outside ring, because we know that's what we're going to add on. And this part of the formula, P times H, gives me that ring. So first I'm going to find P times H. So we're going to split up the surface area into 2 different parts, because some of it we want to add and the other parts we want to subtract. So first we want to find P times H, which perimeter is going to be circumference. So 2 pi times 5, and then times my height, 3. Okay, and then I also want to subtract 2 of the base areas, those 2 small circles that are cut out of the top and the bottom. So 2 times pi 5 squared. Okay, let's find these separately, and then we'll do our final area in just a sec. All right, let's type this in our calculator. All right, for the top one, for my outside ring, I got 94.25 if we round up a smidge, and that's still meters squared. Okay, and then for the bottom I got 157.08 if we round up a bit for that one as well. So super small rounding isn't going to mess with our answer too much. But we want to find the total surface area for our shape. So what we want to do is take the full one over here, 678.58. We want to add on the outside ring, which is this 94.25. But at the same time, we want to subtract the top and bottom small circles. So minus 157.08. All right, let's type that in and see what we get. Okay, for the total surface area, I got 615.75. Our units were meters squared. So that is going to be the surface area of my composite donut-like shape over here. So surface area is definitely a bit trickier. It's not always this tricky because we're not always working with cylinders, but cylinders are definitely one of the hardest things, especially when we have cutouts and we're finding surface area. That's when it gets really complicated. But I want to show you that it's not always so complicated. So we have these 2 examples over here on the right. We're going to start with surface area of this shape here, and then we're going to do a cutout of volume to kind of flip-flop what we just did and show you that it's really not too bad. So first, we want to find the surface area of this shape here, but I want you to tell me, what is this shape composed of? What is this composite shape composed of? Awesome. I see two pyramids. I think they are squares. Yes, they are squares because we have 2 feet pointing to both of those sides there. So it is a square pyramid, meaning all 4 base sides are the same. And I'm going to use my pyramid formula to find the surface area. So surface area of a pyramid, looking at my formula sheet, we have a half times the perimeter times the slant height. Okay, and then adding on the square base. So we have 1/2 times perimeter times the slant height and then adding on the base. But notice that the base is actually not part of the surface. So we really don't need to add on the base for this one. But we are going to need to double this because we have 2 identical pyramids. Notice that their heights are the same. So what we're given here is actually the vertical height. So we're going to need to do a little bit of Pythagorean theorem to find the slant height. So what we have is this. It is perpendicular to the base there, but we need to find the slant height. So if I dissect that piece, it's going to come out and meet right here. So I know that this length is 2 feet, meaning if we chop it in half, because we're looking at a right triangle, we get 1 foot there, and the height is 1.75 feet. This right here, the hypotenuse is going to be our slant height. So let's use Pythagorean theorem and solve for that. Okay, so the square root of 4.0625. It's going to be really close to 2, but it's not quite 2. So let's use a decimal. 2.015. That'll be fine for our slant height. Okay, 2.015 is our slant height. Now we need to plug it into our formula up above. So the surface area of one of my pyramids is going to be 1/2 times the perimeter. Perimeter of a square is 4 times the side length, which is 2, and then multiplying that by my slant height, which was 2.015. Okay, let's see what we get there. All right, for one of the pyramids, I got 8.06 for the surface area. Remember, we are not adding on the base, so we actually cross that part out of our formula. It's not visible on the surface. It's inside of this composite shape, so it's not a part of this outside surface. But I do have 2 identical pyramids, so the total surface area is actually going to be double that amount. Okay, so I'm going to take 2 times 8.06, which gives me 16.12. Our units were feet, and surface area is squared. So my final answer is 16.12 feet squared. Okay, not as bad as the other one. Sometimes we're not given that slant height, which makes it a little bit more complicated, but not too bad. Okay, one last one. My notes are looking all over the place, so hopefully you have room on your paper. First, we need to identify what shapes we're working with. Awesome. I see another rectangular prism, and outside the middle, I see a cutout cylinder. So we're going to actually use 2 different formulas here, finding the volume of the rectangular prism and then subtracting the area of the cylinder. So first, let's find the prism volume. For prism volume, we take the base area times the height. Okay, and the base area here is not a square this time because I see 10 and 14. So the base area is going to be 10 times 14. And then we multiply by the height, which is 12. So 10 times 14 times 12, what does that give me? Awesome, it is 1680, and that is inches cubed because volume is cubed. So this is most of it, but we actually need to subtract the cylinder that's in the middle. So we need to find the volume of the cylinder and then subtract. So the volume of a cylinder, we're going to use the volume of a prism formula, but our base is circular. So we're going to take the area of the base, so pi, my radius is 2. It's labeled there for me. And then times the height. So the height of this, it looks like it's the full height of the prism. So it's also going to be 12 here. Okay, so we just need to plug that into our calculator and see what we get. So we either get 48 pi, or if we got a decimal, it is 150.8. And the units here are, again, inches cubed. So the total volume, good thing I use different colors because we would be very confused if not. Okay, the total volume is going to be the 1,680 minus our 48 pi. And if we wanted to leave it exact, that is how we would leave it. If we find our decimal, what would we get? Awesome, we would get about 1,529.2 inches cubed. Okay, either one of these works. It just depends on the instructions. Do we want to leave it exact, or are we okay with an approximation? For the project, that is totally up to you. For your assessments, that's always labeled how we want your answers. So I hope this kind of helped out a little bit. This is going to be all for today, so we will see you tomorrow with some practice. Let us know if you have any questions.